dominate, literally a handful of them, right, who dominate the field. And the cost of training a single frontier large language model like ChatGPT 5 is about $2 billion, billion with a B. And total development costs maybe lie around 50 billion. Energy costs for training is in the order of 100 gigawatt hours. And running costs, operational costs, are about 4 times the electricity use of the city of Kanpur every day. Now, it's time that we begin to imagine the unimaginable in regard to AI, a cheap and ubiquitous AI. So why do we think this might be possible? Well, AI is the business of imitating human beings, human intelligence. And human intelligence is already cheap, distributed, plentiful, democratic, right? Running a human being takes a few hundred watts, and running a brain is about 20% of that. So we're talking about the energy at the scale of a light bulb. Now, that gets you training, continuous updates, daily operation, right? Plenty of room for a jungle of innovation, specialization, diversity of expertise. So what's holding us back? So 2 factors. One is that we need to understand how human beings learn. How can we be so efficient? And the other is how can we code this efficiency into our new models? Now, where do we start? How does a little baby's brain, needing only the power of a light bulb, learn to speak any language reliably, right, in a few years? So we know how a classifier is trained with plenty of thousands, right, labeled examples. Deep neural network breaks the training data into trillions of data points and computes in the combinatorial space of these trillions of dimensions, right? And this is where the energy is going. This is where the cost is, right? Massive search in spaces that, for the most part, contain nothing, right? Where there are no relations to detect, but you have to search through everything. So how does the baby constrain the search space? We know a little bit about it. We know that human cognition works by constantly constraining the search space. Knowledge, for instance, of knowledge is structured into modules and related into dynamic relations. Now, if you show a small child, right, his first cat, he will form not only the recognition of the category, a cat, but even the generalization of animal, and he will begin to be able to, with discrimination, transfer some of the information he knows about cats to information about animals in general, and to transfer that into other animals that he's encountering. He will likely know that the cat has 2 eyes, 2 ears. If he sees a cow, even from behind, he will make a good educated guess that the cow is similarly going to have a face, a nose, that it's going to eat, that it's going to poop, that it's going to walk. And in addition to this kind of categorical learning, the child also learns statistically. Some events happen more frequently than others. Some features are more common. And as the child is exposed to more information, his database is continually enriched. At every steps, he crops the search space. He reduces the computational load. Instead of a vast training database, he needs a single instance to learn a new classifier. And that doesn't just give him recognition, that gives him a half-filled database already of reasonable, plausible predictions. So we need to do the same thing. We need to structure knowledge. We need to combine categorical and statistical learning to form structured and relational mini worlds that connect to each other and that expand systematically in multiple directions. We need heuristics of wayfinding to avoid the expense of fruitless searches. The Red Hen wants to pioneer the tools, the applications for pruning out the exorbitant wastes of AI. Human intelligence doesn't come in some vast monolithic superbrain cooled under icebergs or under the sea, right? Costing hundreds of thousands of gigawatts to train and run. Human intelligence is massively distributed, ubiquitous, cheap, seamlessly integrates training with performance, flexibly innovates. And in the last couple of decades, we've seen the triumph of computational power, of hardware, of GPUs over intelligent modeling. Hardware has taken the crown over and over. But we're butting up against the limits of how far we can scale. We may already be very close to the point where further improvements along this dinosaur route of bigger and bigger super efficient machines has reached the limit of what we can afford. It may simply be so expensive that it will never pay for itself. The machines, the energy is starting to build a wall. Now, that's nothing to be ashamed of. We already know we can do way better. We ourselves are the living proof. Go for it, Mike.
Hello. So, a human being's brain, as Francis says, takes the energy of a light bulb. And um, suppose you have 25 of them. That's about the size of a tribe back in the upper Paleolithic, or even if you advance it to 125. Okay, 125 light bulbs. And a group of 125 human beings is awesomely intellectual and formidable. Evolution has found a way for there to be shockingly great intelligence within tight energy constraints. Current AI has not managed to do that. Now, we love current AI in Red Hen. I've been doing this since 1970. I teach symbolic AI. I taught parallel distributed processing and connectionism. I teach generative AI. But this particular model of the sort that Francis has just described is not the one that we see in human systems, which are energy efficient and work not alone, but in concert distributed cognition with other human systems and dogs and cats and with nature. We can see a way to run an organization, informal, globally, with lots and lots and lots and lots of small open source systems that are like human systems trying to find their way according to certain kinds of constraints. We think it's time to launch this global open source small AI program. Red Hen Lab has been working in this direction for many years. And this is what we propose to mentor in developers worldwide. See us at redhenlab.org. See the many projects that we have been running over the past 20 years and come up with ways in which your project could operate in this Red Hen system. Francis?
Yeah, so we may do this through Google Summer of Code. We may do it independently. We're open to your suggestions.
Peace out. Thank you for your time.
each. Microsoft events, and sometimes little face problems. KDE 5. We maintain both versions of KDE 5 and 6 in one repository. Most other distributions package only KDE 6. For example, Fedora and Debian. But we in Rosa keep both versions of KDE because people who made patches, we have upstreamized many of the patches, and updates do not introduce new bugs while fixing all the bugs. So we give choice for our users. Also, we package other desktop environments. For example, this is XFCE. You see the design is a bit different, but it's made so that the background is not white, so that your eyes do not get tired when you work in front of the computer for a very long time. Next slide, please. There is also a very light version with LXQT. It can be run even on half a gigabyte, I mean 500 megabytes operating memory. And the default browser is New Moon. It's Pale Moon with another name. It's a browser based on an old version of Firefox. We use this browser here because it works on systems where there is which have not much operating memory. And this is our version with GNOME. You see, it's also customized GNOME, not pure upstream GNOME 3. But if you want, you can use a pure GNOME. Also, we have an operating system for mobile phones and tablets. It is based on a very, very high customized KDE mobile. That is Rosa Mobile, and it is an Airphone. It is a mobile phone with these operating systems. This mobile phone is unfortunately based on Chinese components because motherboards, processors are not manufactured in Russia, but this phone is built in Russia. I mean, different components are taken and they are built into the entire phone on a Russian factory. Old versions of a phone were built in China, but newer ones are from Russia. My wife also has another copy of a phone. We can give you to test it after my talk, or maybe right now. Her phone is a bit old. It was from China, and mine is from Russia. The pin code is 1234. 1234. And maybe, so I can give it to the audience. You can test it. Please give to next people. Stitch, please. Also, we have a special operating system, Rosa Barrel. It's a model operating system where the operating system is packed into a Squash FS module, and they are loop mounted one on another. It's something like an onion. It's very useful when you have, for example, a computer class or many kiosks. I mean, for example, ATMs, cash point machines, or something like that, on which you need to run the same operating system on each machine. So you prepare the operating system only once, and you distribute the Squash FS images by async, rsync, HTTP, or other methods to all machines. Next slide, please. And you can also use Rosa Barrel from a USB key. It is optimized to be installed on USB key and to avoid breaking USB key with a lot of writes into the file system. It can store data in memory and only flash it into the disk when you switch it off. Rosa company also makes other products for enterprise needs. For example, Rosa virtualization. It is based on OVIRT project with some enhancements. Next, please. Also, there is Rosa Dynamic Directory. It's free IPA, domain management system. Maybe many of you know it. The domain is an LDAP and Kerberos, so a centralized database of users where you can make groups of users and the user logins into the computer, gets a Kerberos ticket, and then can log in into any corporate website or printer or something else, uses those credentials by proving that it is he, not someone else. And the most popular domain system is Active Directory, and most of enterprises in Russia, and I believe in India as well, many use Active Directory as the domain controller. They have Windows infrastructure and they use Active Directory. For example, someone gets a new job, comes to the company, becomes a new member of the company. They make an account for him, and he uses this account to log in into different corporate systems, to email, to his computer, to a web portal, or somewhere else. And when he goes away from the company, his account becomes blocks. And so the administrator blocks the account only in one place, not in many places, and so he does not forget to block him in some of the places of the company. But the problem is that when you migrate a large enterprise installation to Linux, they use Active Directory very often. And you cannot just replace the server with another server because you migrate not all computers in one night. Of course, technically it is possible to migrate, for example, 500 of personal computers to Linux at one night, but in practice it is not very possible. So you migrate part of computers and another part of computers, and while migrating, you have a hybrid infrastructure with both Linux and Windows in it. And so you continue using the old domain controller Active Directory, and you enroll Linux desktops into it, and also Windows desktops into it. So one of the important features of a corporate Linux distribution is compatibility with Active Directory. You at least have to be able to log in. The SSSD program developed by Red Hat does a great job helping to do it. But another important feature of Active Directory is centralized management of computers using GPO policies. And Dynamic Directory solves the problem of migrating to a Linux-based domain controller while preserving the functionality that was present in Active Directory. Dynamic Directory is based on FreeIPA. FreeIPA is a web interface and the backend, which has LDAP, user base, Kerberos, and there is a desktop program written in Qt, which is on the screenshot, for additional management of users. You can set up groups, give permissions, and many other functionality that helps you to migrate from Active Directory. FreeIPA by itself, without the Dynamic Directory plugin, does not do. Next slide, please. Runtime Control Center is based on Foreman. It's a Foreman-based system that, but quite highly enhanced and integrated with other ROSA products that helps you to manage computers from one place. For example, you want to install something on a group of computers, and so you do not have to go to each computer or to manually SSH into each computer. You can do it from a web interface. You can also automatically install operating systems by clicks here and do many different other things, which are important for large-scale corporate deployments. You see here, for home users, design is important, and for large enterprise deployments, both design and some such very not easy to implement things are important. And another important aspect of enterprise deployments is that it is not easy to hire a highly qualified sysadmin, because you may hire one, but you may lose him at any moment. And if he makes very complex, for example, scripts in Bash or Python or something like that, then a new sysadmin will come and he will not be able to manage your infrastructure if it was something very customized. So large enterprises tend to buy a big product that can do a lot of things, but has documentation, has a graphical interface, so that they do not depend from the qualification of the admins so much. And that is a very important aspect that is different between enterprise and home users. Next slide, please. Yes, and one more thing. In Russia, there is the situation is that when the USSR crashed in 1980s, too few children were born, and so now more than 30 years later, there are few people who can work, but there are a lot of jobs, open vacancies. So there is a lack of job force, and that is why salaries grow, salaries become higher, but it is very hard to hire a highly qualified person. That is what makes Russian economy different from some other economies. And that is why we, for example, are not afraid of automatization, because some countries say that, well, we can automatize some operation, replace people with robots, but people will lose their jobs, so let's do not use robots. But we in Russia do not have such problems, because we have a lack of people, so we can easily replace them with robots, and we try to automate as many things as possible. And so I have spoken about people resources, and the Rosa Resource Manager is a managed IQ-based product that manages virtual machines running in different virtualization systems, including Rosa virtualizations, in cloud deployments, etc. It helps to optimize the use of hardware resources, and it also allows users to, so to say, buy a virtual machine by themselves, to rent it or something like that. Next slide, please. So, why to use Linux, not Windows? If we can just use Windows and maybe have no problems, as we can think. First of all, well, to my mind, Linux is in many aspects technically better than Windows, and it makes it work more reliably. For example, I know a person who is older than me. He, somewhere about 15 or 20 years ago, had his own company that specialized on IT. So he installed Windows, he managed it, something like that. And he did not like Linux even at that time, 15 years ago, when Linux was not so well suited for desktop. Because he installed Linux and it did not break. So he did not get new money for repairing it. And he liked Windows very much because it helped him to earn money. Because he installed Windows, then they caught a virus or did something else, and then he could come again and earn additional money. And as I have already said, in many aspects, Linux works out of the box much better than Windows. Of course, in not all, but in most common aspects it is so. And if you need a program for Linux, for example, you want to make 3D models, you can just install Blender from the repository. You can just open your console and run sudo dnf install Blender, or you can open a graphical package manager program, dnf dragger, type Blender, click install, and it will be installed. It will take just about 2 minutes. And on Windows, you have to first find a website, then download something that is very big, for example, 1 gigabytes, not a few 100 megabytes on Linux. And you also have to see that you do not download a virus. And so it is not easy on Windows to install software. And if you take your, for example, grandma or grandpa and teach him, it will be much easier to teach him or her to install software on Linux than on Windows. And Windows sometimes make very big changes in the UI, in the graphical interface, that are very hard for some people to adapt to. For example, here on the image is the start menu of Windows 8, Windows 7, and Windows 11. They just break the user experience. They completely break it, even by such stupid solutions as moving the start menu button into the center of the screen. Because when it is in the left corner, you just take a mouse, drag it to the corner, and you click it. And when it is somewhere else, it is very hard to get into it. And in Linux, we have freedom. If we do not want to make UI changes, then we do not make them. And if we make our own distribution, not based on, for example, Debian, then when someone makes some change, not only in UI, then we can make just the default setup as we think it is needed. But when you make a distribution based on another distribution, you always choose between either keeping a difference between the mother distribution and yours, or accepting their strategy. And it consumes a lot of resources to maintain this difference between your distribution and another distribution. And also, when you make your distribution, you of course understand how it works much better, because you package all the packages, that all thousands of packages. And when you make a Debian or CentOS-based distro, you just build, for example, customize only 10 packages from 1,000. And so you just know not very well how it really works, your distribution.
Screen share is stopped.
Maybe it would work a bit better if it was Linux. And another aspect of Windows is that, well, of course it has good backward compatibility. For example, you can run programs which were made 12 years ago on modern Windows. But in practice, for example, I had a multifunctional device, scanner and printer, in which scanner could not be made work on Windows 10. But I installed a modern, from that time, Linux, just downloaded an old proprietary drive. It was 15 years old, proprietary driver blob. The operating system was 64-bit and the driver was 32-bit. But I installed it and it worked. And I could not make Windows work. So even backward compatibility in this hardware in Linux is actually better than in Windows. Next slide. So I have already said many of these things, but what we met with in Russia was that Microsoft simply stopped selling licenses in Russia in 2022. Due to sanctions, they had to stop it. The government, the American government, told them to stop working in Russia. So if you are a big enterprise, for example, a bank, you develop your business and you buy new computers frequently. For example, your old computer broke, or you open a new office and you have to put new computers into it. And all of your infrastructure is Windows based. Your servers are Windows, your domain controller is Active Directory, your desktops are Windows, and your admins, sysadmins can only work with Windows. And one day you cannot buy new licenses. So you just cannot make new computers work inside your infrastructure legally. It's not the biggest problem that could happen. If they wanted, they could, for example, send an update that would not immediately, but for example, in a few months, just block work of Windows on Russian computers if they wanted to do it. Technically, it is absolutely possible because we do not know what they really make by updates. All updates are black boxes. We have no source code. We cannot control them. And so they could do it. Or maybe one day they can show some, well, I don't know, some LGBTQ flags inside Windows, and you will not be able to remove them if you do not want to see them and do not want that your children see them, for example. So the solution of these problems is that the operating system must be fully built from source. Of course, we in Russia are not able to write the whole operating system from scratch that will work on modern hardware because, for example, drivers for AMD GPUs are several million lines of code. And if we write such drivers, then all Russian people will develop drivers and do nothing else. So that is why we take Linux, but we built it by ourselves from source code. We study the source codes in those parts that we need to, where there are problems. Some problems, we solve them, we study the source code, we fix it, we send patches to upstream if possible, etc. But the result is fully controlled by us. If we need to make change in any place, we can make it, even in the compiler. Everything is fully under our control. And it is what I call a sovereignized operating system. Next slide, please. Let's take, for example, the Chromium web browser. It's what open source browser on which Google based is Google Chrome. We customize it a bit. For example, we change the default operating system from Google to Yandex because nowadays Yandex search results are better in Russian than in Google because Google went away from Russia. Here there are no suggestions to set up a LGBTQ theme. If you click the customize Chrome in Google Chrome, then you will see such suggestions here. There is nothing bad in it, but nothing good to my mind. I would not like my children to see such advertisement here. What makes Rasa different from other distros is that their version of Chromium is fresh, always fresh. We update it very frequently just after the upstream releases. And if you see other distributions, for example, Debian updated very rarely. We made some a bit hacks to do it. For example, we package the LLVM Silang compiler of different versions. You can run DNF install LLVM 15 or LLVM 20 and other different versions are available from the repository at the same time. And we even built not yet released versions of LLVM because Chromium requires them to build him. And you have either to patch him to be compatible with all the compilers, or you build a newer compiler. We choose to build a newer compiler to avoid patching Chromium. Chromium code base is large. It's only somewhere about 5 gigabytes in compressed form. It is the biggest package in the repository from the source code. And another important thing that is used, that is important to maintain your own distribution is your build system. We use ABF. The website is abf.io or abf.rosa.ru. It is the same, just the same server. You do not need registration to see what is happening. You can go to abf.io, click task monitoring, and see what is happening, which packages are being built right now. You can just have a look. The ABF system allows to first maintain the Git repository of the package, of the spec file. It allows to build the package. Then you publish the result into testing repositories. Then you publish it into production repositories. And when you publish a new version, the older version goes removed so that there is no mess in the repository. So you build package, you maintain a repository of packages, a big collection of packages, and then you build an installation image of the operating system, ISO image, also on ABF. So that's the system that helps to maintain the full life cycle of the operating system. And it is installed not only on ROSA service, it is installed, for example, there is also abf.mos.ru. A link will be later. It's another copy of ABF used to develop the MOS operating system, which is based on ROSA. I will tell about it a bit later. The next slide, please. So here it is. The MOS is an operating system based on ROSA. The MOS team contributes a lot into the repository of ROSA. Where it is possible to contribute to ROSA, they contribute to ROSA to avoid maintaining to reduce the size of their repository. So MOS is a repository of ROSA and a small repository of MOS on top of it. It is an operating system that is already used on mostly all computers in Moscow schools. So it's on computers, laptops, monoblocks, and interactive panels. I will show you a photo a bit later. It is also used in other places than schools, so it is a very large-scale installation of desktop Linux. And for example, Alexander Pesner, who unfortunately did not come here due to problems, he works with the MOS team, so the MOS team works closely with ROSA team. So we all work closely together to develop the desktop Linux, and when we started MOS, we met with a lot of different printers and scanners in schools, because there were very, very many different scanners, printers, and that's why we greatly improved compatibility with different scanners and printers out of the box. So we included some additional drivers, we packaged some new drivers, we patched some drivers to support additional printers or scanners, etc. And now ROSA and MOS probably supports more printers and scanners out of the box than other distributions. And Alexander develops, for example, SAIL AirScan and IPP USB, which allow most of the modern scanners and printers which support Apple AirPrint AirScan protocols to work on Linux out. And these programs are included in most desktop Linux distributions nowadays. But our distribution is a place where new versions get packaged quickly and with direct information from the developer. Next slide, please. And now, so when you saw the screenshots of the operating systems, you probably noticed that they look a bit like Windows. In Windows, you have buttons to close, open the windows on the right, in the right corner, right up corner. You have the start menu in the left corner, etc. So the user experience is actually the same. One slide back, please. So, and you see that the color of icons is not as in Windows. They are blue, they are not, for example, yellow. But according to our experience, it is not really important which color the icons are, because users detect where they have to click, not by color, but by its visual appearance in general. They understand that they have to click here, or to click here, or that they can close the window by a button, and it is not really important the color of the button. And that's why, on the other aspect, there are some desktop Linux distributions that try to maintain very, very high visual compatibility with Windows, but usually they have a bit not finished design. And we try to make our own design, let it be much, we try to make as consistent as possible. Next slide, please. So, as I have already said, when you made enterprise deployments, you have to think about some aspects that home users don't think about. For example, centralized management, GPO policy support, domains, and even such strange things as two-factor authentication or authorization. I always forget the difference between two words. Then, if you take pure KDE in Debian, for example, or Fedora or somewhere else, you actually will not be able to log into it using a smart card. Smart card is something like a bank card, but with NFC chip, and you have a special card reader. You insert your smart card into it, and you enter your PIN code, and then you get logged into your computer. And when you remove your smart card, your screen must automatically lock. If you take pure KDE and their SDDM desktop session manager, it will not work there. But if you take ROSA and set up it, it will work. We currently use GDM GNOME desktop manager in ROSA because it works much better with domains, two-factor authentication, smart cards, and such things in ROSA. And actually, it integrates well with KDE. We are right now developing a KCM module to graphically set up automatic login in GDM via the KDE settings. And maybe one day we will, the most team contributes to the SDDM manager. You can see the comments on GitHub, and there is Sergey Katunin there, who has commits upstream. But unfortunately, SDDM in general is not yet fully compatible with corporate needs. That's why we use the GDM login manager, which works well with smart cards. It can even automatically log in when you insert a smart card. You enter the PIN code, it automatically asks for PIN code, you enter it, and yet you get into a desktop session, and you can even it can even check if you can log in via the domain controller, Active Directory or free IPA, free IPA to be more correct. But when you remove the smart card, your screen in KDE does not get locked. And we made it lock automatically. We patched the GNOME component, which locks it automatically to be able to run also in KDE. It is a lightweight component. GNOME, well, I forgot its name. because there are a lot of them, and our repository is one of the biggest in the world according to repology.org. ROSA repository has many packages. We have somewhere about 20,000 source packages, so I cannot remember all of them. But we patched it a bit, and if you install a special package that allows you to log into Kudu with smart card, then everything else will work out of the box. You remove a smart card, then your screen gets loads. So I think that if you're a pure home user, you never thought about such features of Linux desktop. You never need them, because if you are healthy mind, you probably will not make so strange setups, so complex setups. And Doug, next slide, please. Next slide. Yeah, and another type of devices on which ROSA and most operating systems are quite widely used are interactive panels. So here's a whiteboard on which physical whiteboard, and most schools in Moscow, all schools in Moscow now have interactive panels. It's a very big touch screen like this. It's either on the wall or on a special legs. It's bigger than this. It's wider, but it is not. There is no projector on it. It's just a screen itself. So it's just a very big screen, and it has a simple computer with Intel CPU, or maybe even with Russian CPU Baikal. And just this computer, but it's touch screen, so we have to make some optimizations for touch screens. For example, you see that here there are bigger spaces, so that it is easier to get to needed place by your finger. You can point with 2 fingers, and right-click mouse right-click will be emulated. You can use some other gestures. Also, one slide, next slide, please. There is an on-screen keyboard. We are working on trying to make it appear automatically when you start typing the text. It's unfortunately not easy to implement, and it currently does not work with VLAN, so only X11 is used here. But in general, the experience is very good. You can even run, teachers at schools even run Blender 3D modeling on such interactive panels. You can, next slide, please. And you can edit documents. And another important program for corporate usage of desktops is an Office. The program with which you edit text, documents, tables, and sometimes presentations. And the MOS team contributes into the upstream LibreOffice. Here are the names. I mean, Galif and Vladislav Tarakanov. You can find the commits in the LibreOffice upstream if you want. They contribute to the LibreOffice, but their patches get into our package, into our repository before upstream. So they make a patch for the latest Git master, latest upstream version of LibreOffice, and then they backport these patches to the current stable version. And here is the link to the Git repository of the LibreOffice package in ROSA. All ROSA packages are Gits. Of them are here above io/import. You can have a look if you are interested. It's a simple Git, just as GitHub. As LibreOffice is a ROSA package, they maintain the changes not in a separate repository, but in the ROSA repository. It makes both teams benefit from each other. And it's easier, for example, for them, because if a library is updated, it changes IP, we have to rebuild the LibreOffice package, then it is rebuilt in the ROSA repository, the whole repository is kept in sync. And nowadays, LibreOffice supports docx formats very well, much better than, for example, 10 years ago, much better. Most of the Microsoft Office documents are opened without any issues. Issues are very rare. You have a question? Okay. What does it mean? Okay. Next slide, please. but unfortunately the whole process, no, it simply physically cannot be fully easy. It cannot be very easy